So today we're going to be going over the Chinese Remainder Theorem, which states that if we have a number x modulo a prime number equaling to a constant, the same variable x equaling the same x modulo a prime equaling to a different constant, this will be able to solve what the x is. So the first thing when we get the Chinese Remainder Theorem is do the same steps as the extended Euclidean algorithm. So we're going to take our larger prime number modulo our smaller prime number, which is 13, equaling to 6, and then 13 goes into 9 only one time, so we'll keep a note on that. And then we will have our modulo number drop down, modulo whatever our remainder is, which is going to be 6, equaling to 1, and then 6 can go into 13 two times. So we're going to write a 2 there. And now we get 6 modulo 1 is equal to 0. However, 1 can go into 6 times. So now we have all we need to use the Chinese Remainder Theorem. So with the Chinese Remainder Theorem, we're going to set up this kind of chart where we have 1, 0, and then 0, 1. And this column right here, these two spaces will be empty. However, we're going to need a row for every row that we have during our extended Euclidean algorithm. So since we have 3 rows here, we're going to need 3 extra columns. So this will be 1, 2, 3. 3 extra rows. So now what we need to do is we need to write what we have in the brackets into this column. So this will be 1, 2, and 6. So now, the way the Chinese Remainder Theorem works is we will take the number 2 spots up from the box we're in and write the number at the far left, and then we're going to subtract our box right beside and right above where we are. So this is going to be 0 multiplied by 1. While our box here is going to be 0, because that's 2 boxes up, minus 1 and 1. So this will be 1 multiplied by 1, which will give us negative 1, while our other box will just give us regular 1. Now we just follow the same steps. So for this box, we're going to go up 2. So this will be 0 minus the box beside it, which is 2, multiplied by the box right above it, which is 1. So this will give us negative 2. And now this box will go 2 up, which is our 1. So this will be 1 minus 2 times negative 1, which will give us 1 plus 2, so this will be 3. Then what we'll do is we will look at our column and we'll notice that this is our final row, but it will be equal, this is where our remainder is equal to 0. So this is where we know that we want to stop. So we can cut this row off. So now we get our 2 answers of negative 2 and positive 3. So now what we need to do is we need to take our answer from our left column, which is our negative 2, and multiply it with our larger prime, which is our 19. And then we need to multiply it with our answer from the opposite equation. So this will be 11. And now we have to add this with 3, which is our rightmost column, multiplied by our smaller prime number, and again the answer from the opposite equation, which means this will be multiplied by 10. And this will give us negative 28. However, if you remember, to make it a positive number as our answer for the modulo, we need to add our number that we're taking the modulo. However, in here we have 19 and 13. So what we need to do is add it with 19 multiplied by 13, which will give us 219. And now this is going to be our answer, because if you check, you can do 219 modulo 19 will give you 10, and 219 modulo 13 will give you 11. So now for question 2, we have x modulo 17 is 15 and x modulo 19 is 8. So again, we're going to use the extended Euclidean algorithm to give us our larger prime, which is our 19 modulo 17, which is going to give us a remainder of 2. However, 17 goes into 19 one time. And then we'll drop our 17 down, making a 17 modulo 2, which will give us 1. But 2 goes into 17 8 times. And now we have 2 modulo 1, which gives us 0, and this will go into, and 1 goes into 2 times. However, if you remember from the first question, the row that equals to 0 doesn't matter, so we can just cross it out. So now, when setting up our chart, we'll start off, like always, with 1, 0, 0, 1, and then we will have our answer here, which will be 1 and 8. And now, following the same steps as the last question, we will go start at our first box, go 2 boxes up, and this will be 1 minus, and now the box beside it and above it, which is 1 multiplied by 0, which is 1. And again, this will be 2 boxes up, which is 0, minus 1 and 1, which will just be negative 1. And now this will be 0 minus the box beside it and above it, which is 8 multiplied by 1, which will give us negative 8. And here we'll get 1 minus 8 multiplied by negative 1, which will be 1 plus 8, which will be 9. So now what we do is, again, we'll take our leftmost column, which is negative 8, and multiply it by our larger prime, which is 19, and then multiply it by our opposite answer, which is 15, and that will add 9 multiplied by our smaller prime, which is 17, multiplied by our opposite answer, which is 8, which will now give us negative 1056. And you can think of it as modulo 17 multiplied by 19. And this will change to equaling negative 1056 modulo 17 times 19, which is 323. Now if you notice, if we have negative 1056 and just add 323 this time, we're still going to be stuck with our negative number. So we need to treat 1056 like a regular modulo question, which, if you remember, what we need to do is just take out the negative and then do 1056 modulo 323, which will give us 87, and don't forget the negative, so negative 87. And now this is a number that we're able to work with because we can just add 323, which will give us our final answer of 236. Then if you test it, we'll see that 236 modulo 17 does in fact equal 15, and 236 modulo 19 does equal 8. So now our final question is x modulo 101 is equal to 37 and x modulo 199 is equal to 113. So again, what we'll do is our normal steps of the extended Euclidean algorithm, which is going to be 199, our larger prime, modulo our smaller prime of 101, which will be 98, and we only have 101 going into 199 one time. And then we'll get 101 modulo 98, which will be equal to 3, and again 98 goes in 101 one time, and now we get 98 modulo 3, which will equal 2. However, 3 goes into 98 32 times, and then we get 3 modulo 2, which is 1 with 1, and then 2 modulo 1 is 0. However, since it is equal to 0, this row does not matter, and we can discard it. So now setting up our chart, we get 1, 0, 0, 1, and we'll see that we need 4 extra spaces. So we'll get 1, 2, 3, and 4. And we'll put our numbers 1, 1, 32, and 1. So 1 minus 0 multiplied by 1 is just 1, and then 0 minus 1 times 1 is negative 1. And then we get 0 minus 1 times 1, which is just negative 1. And this one will be 1 minus 1 times negative 1, which is 1 plus 1, which is 2. And then we get 1 minus 32 times negative 1. So this is 1 plus 32, which is 33. And this will be negative 1 minus 64, which is minus 65. And then here will be negative 1 minus 1 times 33, which is negative 34. And we get 2 minus 1 times negative 65, which is 2 plus 65, which is 67. So now making a little bit more space for our last step, we will do negative 34, which is our left column, multiplied by our larger prime, which is 199, multiplied by our opposite answer, which is 37, plus 67, our right column, multiplied by our smaller prime, which is 101, multiplied by our opposite answer, which is 113, which will give us our answer of 514,329, which if you test in both of these, x 514,329 modulo 101 will equal 37, and same thing for modulo 199, it will equal 113. But since this is such a large number, we're actually able to reduce it. So the way to reduce it is going to be taking 514,329 and taking it modulo our two mods, which is 101 multiplied by 199. And this will be equal to 11,854. And then again, if you test 11,854 modulo 101, it will equal 37, and 11,854 modulo 119, it will equal 113.